Hi guys, in this video we're going to go through vertical projectile motion in one dimension. We'll just go through the definition, then we'll do an example from a past paper that has been adapted for this video. We'll use the equations of motions, and we'll also draw a graph. We'll go through it quite quickly because you should have experience using this or doing this in grade 10 and 11. So let's move on. What is a projectile? A projectile is an object upon which the only force acting is the force of gravity. So it's basically in free fall, and the only thing that's working on it is gravity. This here in this table are the equations of motion, and you should know them by now. Basically, in this type of question, all you have to do is really choose the right equation. To do that, you look at what variables you have, so you write down what you're given. And then you look at what you're asked to calculate, and so you look what's unknown, and then you basically plug into one of these equations where there's only one unknown, and you can get the value. Just some notes before we actually do the question that you should know, and just a reminder. The initial velocity is equal to minus the final velocity. This is like for a projectile. So for example, if you're throwing a ball from here, and initial velocity is 6 meters per second, and it goes up all the way here, then it stops here. At the top of the projectile motion, velocity will be equal to 0, so the ball is stationary, and it will come down again to this position here. And the final velocity here will be equal to minus the initial velocity. So from wherever it's thrown, so if it was thrown from the ground, the final velocity will be negative whatever the initial velocity was. Then again at the highest point of the projectile motion, velocity equals 0. The time it takes to get from the bottom here to the top here is equal to the time that it takes to get from the top to the bottom. So that's like pretty self-explanatory. If you have a ball in your hand and you just throw it up and catch it, you can see this quite easily. And yeah, the last thing is that the only force that's acting on a projectile is the force of gravity. And gravity is equal to acceleration in this case, and that's equal to 9.8 meters per second. But if you take upwards as positive, like we usually do in these type of vector situations, then acceleration will be minus 9.8. That's very important, there's a minus there. Okay, now that we have these notes out of the way, you're more than welcome to write it down. Pause this video and write that down. These formulas will be given to you in the exam, so yeah, you should familiarize yourself with it. Right, so let's do this question based on question 3, I think it is, from December 2015 final exam, paper 1. So it goes like this: a ball X is projected vertically upwards at a velocity of 17 meters per second from the ground. Ignore the effects of air resistance, use the ground as zero reference. The first thing they want you to do is calculate the time taken by the ball to return to the ground. Okay, so let's do this. We can just make this a little small. Okay, let's just draw a quick diagram of what we have here. So ball, there's the ground here, there's a ball here, and it is projected upwards at 17 meters per second. Right, so let's calculate it. So let's see what we have. So that's initial. Right, so using the information given, just a little bit. Sorry. Right. So we have that velocity initial is equal to 17 meters per second. Velocity final could be equal to minus 17 meters per second because they asked for the time to return. Acceleration is equal to minus 9.8 meters per second squared, and they want you to find the time it takes to get from initial to final velocity. Right, so it's quite straightforward. So we have final velocity, initial velocity, acceleration, and change in time. Which of these equations can we use? We can use, we're not really looking for position, so we don't really need to you don't have to really worry about any of the ones with position. So we won't worry about this one here, we won't worry really about that. We could use this here. No, we couldn't. There's nothing to deal with time there. The only one that deals with both time and doesn't involve position would be this equation here. So that's the equation we use. Right. So the equation is given as final velocity is equal to initial velocity plus acceleration and change in time. Okay. Final velocity is minus 17. It's equal to initial velocity 17 plus acceleration, which is minus 9.8. And we have a change in time here. Take it across. This is going to be equal to minus 34 is equal to minus 9.8 change in time. Divide both sides by 9.8 minus 9.8, and we get the change in time is actually equal to, if I just plug that into my calculator quickly, 4 divided by 9.8, and we get an answer of 3.47 seconds. That's your answer. And you get about 3 or 4 marks for that. You get a mark for choosing the right formula, substituting, getting the answer. And you get maybe a mark here or there, but that's pretty much how you would work that out. Quite straightforward. This is just using what's it called? Equations of motion to figure it out, right? It's quite straightforward. So we're also going to do the next question, which asks you to sketch a velocity time graph for the ball X. Alright, the following information should be on the graph: initial velocity of the ball, time taken to reach the highest point of motion, time taken to return to the ground. Okay, so for a question like this, you just need to draw a graph like that. You just need to have that. They ask you for velocity time, so that means time is here, and velocity in meters per second is here. Okay. We know that, so basically that's all you have to do. So to set up a graph type of equation, you first figure out what type of graph you're drawing. They ask for velocity time. You write velocity on the y-axis, so you're always going to put your y, and then time is always the x. Just remember that time will always be your x-axis in these type of questions. Then all you do is you follow the steps they ask. So they'll ask you to find the initial velocity, time taken to the highest point, and time taken to return to the ground. So we remember that the initial velocity we started off was 17 meters per second. The final velocity will be the same as the initial velocity, but in the opposite direction. So that's minus 17. The time taken to actually get to the final velocity was 3.47. So we can write that 3.47 here somewhere. Let's say about here. It goes about there, so we know that's 3.47 seconds. And we know that the time from the bottom to the top here is equal to the time from the top to the bottom. So all we have to do is take the total time, which is equal to the time to the top plus the time to the bottom, and divide it by 2. So we take 3.47 divided by 2, and we get the time to 0 to be equal to 1.73. So all you do is you get 1.73 here, and all you have to do is really just show the graph, and that's it. That's pretty much it. That's all you have to do for these graph types of questions. Most of the time when they ask you to draw a graph, just figure out what type of graph it is, and then you put in the positions and the values that you've already calculated. There's a lot more actually to graphs, but it's too much to cover in this video, since we're just doing an example and it's something you should know. At the end of the video, I'll post a link to a page which explains very, very nicely all the different types of graphs and does a lot of examples. It's just too much to explain in this video. So this is almost exactly what you can expect. Like, this is what came out in the exam. And the final question for this was quite a difficult question. It's one of the higher level questions, worth about 5 or 6 marks. And we'll do that now. Right. So let's go through it. It says, 1 second after ball X is projected upwards, a second ball Y is thrown vertically downwards at a velocity of 8 meters per second from a balcony 32 meters above the ground. Refer to the diagram below. So there was a diagram, and I'll just draw that in quickly. It had some sort of building here. A ball, this is ball 2. It was being thrown down at 8 meters per second. And this is, remember, is 1 second after. And ball 1 had the initial velocity of 17 meters per second, in the upward direction. So that's pretty much it. That's all was over there, and then obviously the height here will be 32 meters. Okay, so they want you to calculate how high above the ground ball X will be. This is ball X, this is ball Y, the instant the two balls pass each other. Right, so let's figure out what we're given in this case. Just make this a little bit bigger for myself. Okay. So from the previous question, we know that initial velocity of ball X is equal to 17 meters per second. As positive, initial velocity of ball Y was equal to 8 meters per second negative. Acceleration is minus 9.8 meters per second squared. And that's pretty much it. What they want to know is what will be the change in height they basically want change in height when the ball's height, ball of X, the height of Y is equal to the height of X. That's basically what they want to know, and this will happen at the same time. Right. So here we have to actually calculate two things. They want you to calculate y and time. So there's two unknowns. Whenever there's two unknowns, you need to know immediately that you need to use simultaneous equations. You should have covered this in maths this year. So you should know what simultaneous equations are. So the first thing we'd want to actually do is use an equation that involves the variables that we have. And in this case, the equation that we can use is changing ya is equal to, x is equal to velocity initial change in time plus half acceleration change in time squared. Don't forget the square there. Right. So we'll do the one for x first, and then we'll do the one for y. Since there's two different balls, you have to use two different equations, right? So for the change in height for y, that means change. Remember, whenever there's a change in, it means final minus initial. So we want the final height to be ya, which is the ball is probably going to meet somewhere here at some height y, right? So that ya. So it's final minus initial height of 0 is equal to initial velocity 17 time what we don't know plus half into 9.8 is the negative change in time squared. So if you can just simplify that, that's ya is equal to 17 change in time minus 4.9 change in time squared. And that's your first equation, right? So we're going to do the exact same thing for the second equation. We do the exact same thing for the second equation. Okay. So again, but this time it's for yb, so it's change in yb is equal to velocity initial change in time plus half a change in time squared. Right. So yb is final minus initial. So the final position will be yb minus the initial position, which in this case was 32 meters high. Right. Just remember the change in there. Is equal to velocity initial. The initial velocity was minus 8 meters per second. Change in time is equal to change in time. So that's actually this is the tricky part. This is what's going to catch you out. The change in time is 1 second later. So that means it's 1 second after. So that means the final time minus the initial time. So it's whatever time it is minus the initial time of 1. So you add 1 there. If it was 2 seconds later, it would be minus 2. 3 seconds later, so it's just later, so you have to subtract 1 second or 2 seconds, or how many seconds it is. Right, so this is going to be plus half into minus 9.8. Again here, change in time minus 1, and the whole thing needs to be squared. That's the catch in that one. So we got yb minus 32 is equal to minus 8 change in time plus 8, and we'll have plus 8 plus 8, sorry, that's plus 8 plus, sorry, so be minus 4.9, and in the brackets here we're going to have a change in time squared minus 2 change in time and plus 1. That's basic maths. Let's just simplify this. YB minus 32 is equal to minus 8 change in time plus 8 minus 4.9 change in time minus 9.8 is actually plus 9.8 change in time minus 4.9. And now we just simplify and bring everything to one side. Say YB is equal to, there's only one of these, this was supposed to be squared, yeah? Minus 4.9 change in time squared. Then we have A plus 1.8 change in time. And if we just plug this into the calculator quickly, we have A. So we're done with that. We're done with that and that. What's left is we're going to take this to the other side here. So we got 32 as positive plus 8 minus 4.9, and we get the answer of plus 35.1. So this is your second equation. We just notice that this is just a whole lot of algebra to do. This is usually the case with these sort of questions. Right. So we have equation 1, equation 2. Now we know that when you want it at the same position, they want the height at the same position. So that means YA must be equal to YB. What does this mean? That means that 17 change in time minus 4.9 change in time squared is equal to minus 4.9 change in time squared plus 1.8 change in time plus 35.1. Right, now we group like terms and try and solve for change in time. Okay, what we notice immediately is this is going to cancel with that. We can take the 1.8 plus t to the other side, and we get 17 minus 1.8 will give you 15.2 change in time is equal to 35.1. Then what you do is simply divide both sides by 15.2, 15.2, and the change in time will be equal to 35.1 divided by 15.2, and we get an answer of 2.31 seconds. The thing is, they asked you for the height that x would be above the ground. So what we do is we go back to either formula, but preferably this one here, where it's change in x. I've been using a and b when it's supposed to be x and y, so sorry about that. I can just quickly change it if you like. So that's actually supposed to be x, x, that's y, 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 and y. It's a bit confusing when it's x and y, because y is also the height and x can be position. So that's why they usually use a and b. But yes, so this is the equation that we can use to calculate for the position of x. So that's simply going to be here. Y x is equal to 17 change in time minus 4.9 change in time squared. This is going to be, sorry, time 17 into 2.31 minus 4.9 into 2.31 squared. Don't forget to square that. And the position above ground that they will be in at the same time, minus 4.9 into 2.31, don't forget the squared. We get an answer of 13.12 meters above the ground. So as you probably noticed, this question is quite long and takes quite a bit of algebra, diagrams, so forth. But if you go through it systematically, it's not going to be too difficult. You just have to just draw a diagram, make sure you choose the right equation, and as soon as there's two unknowns or they want you to find something at the same time as something else, then that's when you know you have to use simultaneous equations. It's also, this is one of those difficult or higher level questions, and it can get confusing, especially with the convention of signs. Like, it's important to note which is up and which is positive and which is negative. In this question we took positive as upwards. So make sure you write this actually in your paper so that the marker or the examiner knows which direction is positive and they understand your whole conventions. But that's pretty much how you do these sort of questions. There's a lot more that can go on, but this is probably the hardest type of question where they use simultaneous equations. And there's a bunch of different questions that you can do on graphs, where they have position time, acceleration time, as well as velocity time graphs. So those three types of graphs are very nicely explained here on Siavula's website. This is these are the type of textbooks that a lot of students use, and there's a lot of very good resources, a lot of examples that are done there. It's too much to cover in this video. This video is already over 20 minutes long, so it's quite a long video. I know there's a lot that happened in this video, but you have to also check out the graphs that I mentioned here, if you follow this link here. I'll also put it in the description of this video so that you can access it easily. I highly recommend you really learn all of the graphs and how to interpret it, what the area under the graph is, and how different graphs look, whether it's increasing velocity or increasing acceleration, and what the shape of the graph actually is. But yeah, that's pretty much it. Every single question, every single exam will have a projectile motion question. It'll definitely be multiple choice as well as the question zone.